This is the Earth Science Classroom. Welcome back to the channel. This video is in the Atmospheric Science playlist, and today we're going to look at a thing called thermodynamics, how heat is moving and how it is transferred from our beautiful star, the sun, through space, which is a vacuum, and how it enters the Earth's atmosphere, and how it interacts with the layers, the air molecules, the clouds, and the Earth's surface to heat up different layers, and how this all begins this huge, amazing system we know as the atmosphere. So this video is looking at the basics of how our atmosphere functions, how it operates, how it works as a big system that envelops the Earth. It's the layer of gas and air molecules that are held by gravity and create this thin layer of gaseous material and matter that goes around the whole Earth, held by gravity, and is on average about 100 kilometers thick, which is called the Kármán line, which is the unofficial, kind of official boundary between our atmosphere and the start of space. So this is all about how the Earth's surface and the Earth's atmosphere interacts with radiation and the electromagnetic spectrum of energy that the sun gives off in all directions, and we, the Earth, just grab and receive a small portion of this energy the sun puts out every second, because the sun is like a massive nuclear explosion in space, and it just kind of blasts energy and solar flares and ionized particles out into space, and Earth receives this energy after about an 8-minute delay or traveling time at the speed of light. So as the energy enters the atmosphere, it can change. The energy can interact with air molecules within the atmosphere and the Earth's surface. So it interacts with matter, either gas, either a liquid or a solid, and this changes the energy into different terms or different things. And these things are called radiation, conduction, convection, and advection. Now, thermo means heat, and dynamics means movement or motion. So heat movement and how heat is transferred through different methods, and these methods are radiation, conduction, convection, and advection. Now, as I mentioned, the sun gives off a great deal of energy that transfers or moves through space, which is a vacuum. A vacuum means it's the absence of air molecules. There is stuff in space, but not actual air molecules. So this radiation, this beam of photons, a photon is like a concentration or a suitcase of energy, and it transfers or goes through space and then hits our atmosphere. Now this energy, this bag of energy that is a photon, is a bunch of different wavelengths that are all coming out from the sun all at once. So altogether, this is called the electromagnetic spectrum. Now this comes down to the electric and magnetic fields that the energy produces as it's moving. Now, it comes in different wavelengths. Wavelength is how small or large the gap is between the energy wave from crest to crest. Now, as you can see on the left side at the bottom, we have gamma radiation. That has very short, very small wavelengths, so they're very bunched up energy wavelengths. Now, generally these are very harmful. Then you've got X-ray, again, pretty bunched up, smaller wavelengths. And as we go to the right, we get a slightly larger wavelength, it gets stretched out, kind of. So the next one is ultraviolet, which is beyond the violet color we could see with our eyes, our visible spectrum. So ultraviolet is what gives us our suntan in the summers. And then we have the portion, very small portion or wavelength, that is actual colors or visible light. Our eyes can interpret these wavelengths as colors. So on one end, the shorter range, we have violet and purple and blues, and in the middle we have the greens and yellows, and then on the other side, the longer wavelength, we have the orange and red. So a sunset where the energy is going over or through large amounts of atmosphere, the energy gets stretched out, and that's how we see the color change from a blue during the day to a red and orange and yellow for a sunset. Now then we have infrared, which is basically heat. That's what gives us heat, basically. It's thermal energy. This is beyond the red spectrum, so it's longer and bigger than the red color. Then we have microwave energy, which is honestly a college kid's best friend. And then we have the longest wavelength, which is radio waves. So all of these are packaged in a photon that comes out from the sun and interacts with the Earth in the Earth's atmosphere and the Earth's surface. So I've made this kind of very basic diagram. You have the Earth's surface in this green kind of flat surface, and you have this dashed blue line, which is the top of the atmosphere, around 100 kilometers or 70 miles, which is the Kármán line. And below it you have the different atmospheric layers we know as the troposphere at the bottom by the surface, then the stratosphere with the ozone layer, then the mesosphere, which burns up meteors and is the coldest layer, and finally the thermosphere, which contains smaller sublayers, which is the magnetosphere, exosphere, and ionosphere. So these four main layers make up the atmosphere, and when the radiation comes in from the sun and hits our atmosphere, we have a change of energy into different types based on the air molecules or the state of matter that it's interacting with. For example, when the atmosphere is heated by the radiation, it's mostly heated by the absorption of air molecules like ozone. Or in the thermosphere, where it's just the individual air molecule being heated really high up in the atmosphere. Or, for example, the troposphere, the Earth's surface receives the energy from the sun. And there's physical connection between the radiation, the photons, and the Earth's surface. The lakes, rivers, continents, oceans. There's physical contact. And this contact, where they touch, is called conduction. Now, conduction allows for the Earth's surface to heat up. It's like in the summer when you walk out onto your driveway and your asphalt and the blacktop, and you have no shoes on and your feet burn in the summer because the blacktop gets all that heat from the sun, heats up, and by the afternoon you can barely walk on it. So conduction is touch. And then the atmosphere will come in and touch the Earth's surface, and that will transfer the heat into the lowest part of the atmosphere, which is the troposphere, and then we'll get the next type of energy movement, or thermodynamics, which is called convection, which we discussed many times in this course, and looking at the movement of heat from a hot area concentration, which is the Earth's surface, to a colder area, which is higher elevation or higher altitude in this case. And the heat's going to rise up, so hot air rises and cold air sinks, and you have convection and convection cycles that form inside the atmosphere, especially inside the troposphere. And this is key for forming clouds, having the water cycle, having climate and weather and wind patterns, and all that stuff comes from the movement of heat from hot to cold. Then we have a movement of heat called advection. This is usually side to side horizontal movement, usually by air masses moving from place to place of heat, moving from, let's say, north to south or east to west across the atmosphere along the Earth's surface. And then we have something called albedo. Albedo is just the reflected amount of energy that bounces off the Earth. Could bounce off the atmosphere, bounce off different surfaces, different colors like light versus black, but you have an amount of energy that's going to reflect back out into space. And we'll discuss that later on in the course. So in summary, radiation is just a transfer of energy through photons, generally from the sun, moving through space and the atmosphere. When it reacts with the air molecules and matter, we get a change. We get conduction, which is the touching of energy and the transfer of heat through touch. Convection is a transfer of heat from hot areas to cold areas, like a fireplace or a outside fire pit. Advection is transfer of heat from side to side horizontally across through air masses around the Earth. So a great example of this we can all relate to is when you want to boil some water in the kitchen. You put a little pot of water on the stove, turn the heat on, the flame, and that reacts as the heat source of the sun, radiation. The pots on top is going to cause there to be touch and physical contact, which is conduction. The conduction will create the water to heat up by the fire below, and it's going to cause convection within the water molecules, and you'll have bubbles and evaporation. You'll have movement of the water caused by convection, and then eventually you have evaporation of the water and movement of advection across the kitchen in the atmosphere. As I mentioned earlier, the process or understanding of all these different types of heat movement or thermodynamics is key to understanding cloud development, thunderstorms, extreme weather, lightning, thunder, hurricanes, different weather patterns and jet streams, and all our weather and climate across this country and the planet. So it's essential to learn these basic terms to understand the next level of atmospheric processes. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on earth science.